Okay student, now we can discuss the stability of coordination compound. Stability of coordination compound is the main topic of the stability, where we form a coordination compound. The stability of a complex in solution refer to the degree of association between two species involved in a state of equilibrium. The stability is expressed by the magnitude of equilibrium constant for association. Association, it means it associated and form a coordination compound. For example, M means metal. It's react with 4 mole of ligand and form Ml4 type of ligand. Here minor mistake there. This reaction is right like this: metal plus 4 mole of ligand and produce Ml4 instead of this. Okay. When ligand is associated with metal and form Ml4 types of, at equilibrium, we can discuss about the stability of coordination compound. Larger is the stability constant, is the higher is the proportion of Ml4 that exists in a solution. Larger is the stability constant, the higher is the proportion of Ml4 that exists in a solution. The free metal ion rarely exists in the solution, so that metal will usually be surrounded by solvent molecules which is compete with the ligand molecules and be successively replaced by them. मीन्स जब हम कॉम्प्लेक्स कंपाउंड बनाते हैं तो मेटल आयन हमारा क्या रहता है, तो कि टोटल सराउंडेड रहता है लिगेंड के साथ, और उसके साथ मेटल आयन compete करता है और उसको बाद में सक्सेसिवली रिप्लेस करता है और डिफरेंट टाइप ऑफ ligands प्रोड्यूस करता है. Which is different type of ligand. Right here we stepwise, let us consider the stepwise association of metal ion and ligand ignoring solvent molecules. It's ignore the solvent molecules and form a complex compound. Some minor mistake in this structure, we can write like this: metal react with 1 mole of ligand and produce at equilibrium condition Ml type of ligand. And second one, if metal ligand means Ml react with another 1 mole of ligand, it produce Ml2 type of complex compound. And Ml2 type of ligand compound react with 1 mole of ligand, produce Ml3 type of ligand. I hope you can now understand how is the possible of Ml, Ml2, Ml3, Ml4, Ml5, Ml6, Mln type of ligand are how to produce. It's simple, just Mln type of, it means the metal n atoms of ligand n minus 1 number of ligand react with another ligand and produce Ml n moles of ligand, Mln type of ligand. And its equilibrium constant, we know about equilibrium constant. Equilibrium constant is basic formula is the concentration of product divided by concentration of reactant. If you know in your 11th standard equilibrium chapter, equilibrium constant formula is equilibrium constant K is equal to concentration of product divided by concentration of reactant. You know about that concentration of product and concentration of reactant is called equilibrium constant. Okay, now see this reaction we have. This is the our concentration, this is the our product Ml4 and this is our reactant. Wait a second. This is the our reactant and these are the our product, same as reactant and product, reactant product, reactant and product. So we can write equilibrium constant for K is equal to, for first reaction is K1 is equal to Ml upon concentration of Ml upon concentration of M into concentration of L. See this, we can now write this concentration of product, concentration of second, same reaction in second reaction, concentration of product divided by concentration of reactant. Concentration product is Ml2 and concentration of reaction reactant is Ml and L. And last one is for our MLN type of K4 is equal to MLN by MLN minus 1 and L. Where is the K1, K2, Kn? We can write of this here Kn. It is a Kn, not K4. K4 it means here 4 mole of, here 4 mole of ligand. When attached, we can consider as K4. Okay, where K1, K2, Kn etc. are stepwise stability constant, the overall stability constant beta of the formation of species MLN from M and L can be given as like reaction in short form. We can write like this. This reaction we can write like this: M plus 4 mole of L, n mole of L, n mole of L at equilibrium condition, product is MLN, and beta stability constant, overall stability constant is beta n concentration of MLN upon concentration F, concentration of M and concentration of L n times is equal to K1 into K2 into K3 into dash 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 Kn. I hope you can now understand the formula how to we can calculate overall stability constant. It's very simple. Overall stability is equal to a product of all stepwise stability. Consider the formation of cuproammonium ion CuNH3 4 times 2 plus obtained by stepwise addition of ammonium molecules one by one. We can write first of here our metal is copper and ligand is ammonia. First of all, one ammonia is attached, then we can write CuNH3 2 plus, and if two ligands are present, then we can write CuNH3 twice 2 plus, and if three ligands are present, three ammonium molecules are present, then we can write CuNH3 thrice 2 plus, and if 4, then CuNH3 4 times 2 plus. If K1, K2, K3 and K4 are stability constant of successive reaction respectively, then we can write B4 CuNH3 4 times 2 plus upon concentration of Cu2 plus and concentration of ammonia is exponent is 4. Because of we can write its reaction like Cu sorry Cu 2 plus 4 mole of ammonia and give product Cu NH3 4 times 2 plus. Okay. Okay. The addition of 4 amine groups of copper shows a pattern found for most formation constant, in that the successive stability constant decrease in this case of 4 constant are. For example, K1 is equal to 4.0, K2 3.2, K3 2.7 and K4 is 2.0, or B4 is equal to 11.9. Because of B4, it means the B4 meaning is the dissociation constant is a reciprocal of formation constant. Dissociation of constant is reciprocal of formation constant. It is the main point to note down this. Reciprocal of formation. So we can write like this, B4 we can write this dissociation equilibrium constant, sorry, dissociation equilibrium constant is equal to reciprocal of stability constant. Reciprocal of stability constant is equal to 1 upon beta 4. I hope you can now understand of this stability of coordination compound. If you can understand, then give likes, and if you have any doubts, then give your comments in comment box. Thank you, friends.